Hello everyone, Mick here, and today I have a showcase video for a device I have come up with, which is a selection sort algorithm, which it sorts out inputs based on signal strength. So this is based on signal strength, and what it will do is that it will sort from highest to lowest, or whatever you really configure it to do. So basically, the inputs will get sorted regardless of what input goes where. So to demonstrate this, I'm gonna make this 15, which is the highest. I'm gonna make this one 2. Note that this is actually the first input. That would be the second. Then I'm gonna make one. What would that be? That would be 13. So we have 2, 15, 13, and then I'm gonna make a 5. So you can see here that's 5. So the sort of order we put this in, like regardless of what way you take it, would be 2, 15, 13, 5, or 5, 13, 15, 2. But the way it's displayed now is 15, and then 13, 5, and 2, which is the numerical correctly sorted way. So regardless, if we change our 15 to be somewhere between 5 and 13 now, so somewhere between 5 and 13, which would be, let's say, let's count out 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we input 10 now, our biggest one will be 13, and then right after we will have a 10, which you can see that's 5 left here, so 15 in total. And if we increase our 2 beyond 5, so we could do, where's our 2? 3, 4, 5, 6, 7. 7 and 5 would swap places. That's a selection sort algorithm, basically. Well, let me get rid of these. So I want to show you a little bit on how it works. So basically, I'm gonna show you with this super high quality chart how selection sort works. On the first block here, we have 2 inputs, and basically, we, on any given sort of row, or whatever you want to call it, we just always compare and send the signal from these down the line here. The reason we just do that is because basically we don't have to check for the strongest one whenever it comes to a row, because the strongest one will just be the one that the comparator outputs. Way to sort of visualize this is that, I'm not gonna make this a full one, it doesn't matter which one of these are the strongest, because the one that ends up here will be the one that is, well, the highest one. So that part is pretty easy. We just send whichever one of these are the strongest, we just send this up. The harder part is that each one of these blocks, we have to compare and find out which one is the lower one. And basically what we do is that we send the lower one down into here. So now the lower one has ended up here and the higher one has ended up here, basically. Now, basically, what we need to do is that we need to compare on the next bit here. We need to compare the input from here, the highest one from here, with this one here. And then again, we send the higher one down and the lower one into here. Now here we compare again if whichever one of these two were the highest, we compare that again here and send the higher one down, and the lower one we send through. Then basically the last one, the exact same thing. Oh well, this is the last one, right? So the highest one will now have been outputted, so to speak. Okay, then here what happens is that we, on the second row, we compare the lowest one from here and the lowest one from here to find out again which one is the ultimate lowest of the two first. And then we output the lowest one here, and we output the highest one here. Now what happens here is that we basically compare the lowest one from here and the lowest one from here. No, the lowest one from here and the highest one from here. Sorry, my bad. And then again we output the highest one here, and the lowest one is sent over. Then what happens is that we compare the lowest one from here, and then we send out the highest one here. And then basically this is the last part. So when we send out the highest one here, we basically just take and send out the highest one here, the lowest one here. You know what I mean? Highest one here, lowest one here. And that is how selection sort works. You just always compare which one is higher and which one is lower, and then you send the. You can like look at it as in like rows and columns. So you just basically send highest one down a column, and then the other one down a row, and then at the end you have sort of what you need. Right. So this is basically. This is like one bit. This is one comparison bit, if you want to call it. And the way it works is that there's two cases for the lowest one, right? So this is case 1 is low, this is case 2 is low, and this is just whatever is the highest, basically. So let's see. If let's say this is, put a sign here. This is A and this is B. So let's say that A is the lowest, and if A is the lowest, then A will be propagated through this thing. So you can see here that A is 13, which would be this one. This is 13, and then you can see that B is basically just a carry line. So what happens here is that we determine which one of them is higher and lower, and we output the lowest one here. And then we just, throughout the entire build, we just carry the highest through this entire line. It doesn't matter really. It just the highest goes through this. It's kind of the easiest part. The way we do this is basically by having input B being the stronger one. We are basically outputting we're basically outputting input A into here, and it goes through this comparator and through this one and into this dust basically. And because output B is stronger than A, which is this one, it has disabled this comparator right here, which doesn't allow this output to be cancelled off by basically powering this. So in the other case it would be that one. Alright, so let's change these up. And now it's basically the other way around, which means that basically it's kind of the same, but what happens now is basically that the lowest one, which is now B, is put out here 13 and then 13. And what happens here is that we're sending the strongest signal down here, and then the strongest signal is sent into basically both this one, strong signal, and also this one, but because they are equal, they cancel out this because it's in subtract mode, which I can demonstrate here. Is that basically if they're equal, nothing happens. Alright, so in this case would be the same if they're actually equal. This one would be the one that carries it over, and basically what happens here now is just that because this one is stronger than or equal to that one, we can't disable this thing. Oh, we would disable this thing basically, and allowing this one not to lock that thing, and we propagate this through this one. Okay, that was quite a lengthy and confused explanation, but I hope you understood that. This thing can be made as large as you want to, so in the end it's gonna be pretty big, but you could stack it vertically, which would probably make for better use beyond your need. But you could, in theory, just keep on adding these modules. So that's about it. Not gonna make a tutorial now. If people want a tutorial, I'm gonna make a tutorial on how to build this. Hope you enjoyed, and hope you learned, and thanks for watching.